Knowing all this, which is nothing else but the first derivative test, now I can say, fine, I have to determine this value and I have to determine this value. I go back to the function and I plug in -5 to determine the y coordinate for -5, and I plug in 1. 1 plus 6 is 7. 7 minus 15 is -8. And I will determine this one too with -5. So -125 and plus 6 times 25 and plus 15 times 5. 100. Okay. Now I need somebody to tell me what is the limit of this function when x approaches -infinity, and what is the limit of that function when x approaches infinity. Which of these three terms is the most powerful one when we talk about infinity?
X to the third.
Yes. So here's my prop. So where does this go when x approaches -infinity?
Negative infinity.
And where does it go when x approaches infinity?
Positive infinity.
Good. So then we know the limits already. At this point, I have to make sure that these two rows go well together. If they don't, I'll say, oops, apologize, and start from scratch. That's when I catch my mistakes. So when the derivative is positive, what does the function do?
It increases.
Is this correct?
Yes.
When the first derivative is negative, what does the function do?
Decreases.
Is this correct?
Yes.
When the first derivative is positive, what does the function do?
It increases.
And it is correct.
Yeah.
Okay, now look at this symbols. Look at the sign and the sign. What type of point is -5, 100?
Relative.
Thank you. Thank you. Max, right? Max. And what type of point is 1, -8?
Roman.
And that's it. At this table, when we continue with this table, throughout this graphing, the first part of applications, the first application, we're going to add another row. I promise, not more, just one more. Any questions on this? Please try to understand this table. It's a very useful table. Okay, moving on. Please feel free to choose other problems, or I will. So we looked at a polynomial. Let's look at a rational function, radical. I can show you what I have here, or you can choose. So anything you want from 29 through 44. I don't know if you can see. Okay, I'll choose 38. Because I'm not sure you can see, or you can choose another function from ebook. Please choose from ebook. So I'm choosing g of x. Same question, everything the same. X to 1/3 minus x to -2/3. Yeah, these problems with fractional exponents are not very friendly. Okay, so first of all, I have to work on this problem a little bit, on this function a little bit. So what do you recommend? Anyone? Any suggestions?
Simplify.
Say it again.
Simplify.
How? I would love to, and that's my goal, of course.
Couldn't we subtract the x negative 2/3 from x 1/3?
Very good. So what Mark is really telling us is to factor out the greatest common factor. Since x is common to both, I have to choose the power that is the smallest. And between 1/3 and negative 2/3, of course, negative 2/3 is the smallest. Let me stop right there for a minute, just in case this is not clear. So if I want to factor from x to the 4th minus 3x squared and plus x, I can only factor the smallest power. This is power 1, power 2, power 4. So when I factor out the smallest power, I remove from 4 power 1 and I get x to the 3rd minus 3. From power 2, I remove power 1 and I get minus 3x. And from power 1, I remove it all, so I have positive 1. So now, by the same token, in the same way, identical, I factor out x to the smallest power. And yes, Mark says from 1/3 subtract, from 1/3 subtract negative 2/3. Yes. What is the answer? So I know what I have left.
It's going to be 3/3, so 1.
Excellent. So this is x minus 1. Great job. Thank you. So now this becomes, oops, x minus 1 divided by, because it's a negative power, it will be the cube root of x squared. And you can say, what's with all these shenanigans here? Why are you doing that? Because not in this particular situation, but I'm not going to differentiate this. Oh, no, no, no. I'm going to differentiate that. But I wanted you to see this situation because we will have to be able to determine the x and y-intercepts. And now I know that g of x, when I get to that, is 0 when x is how much?
Zero. Or x would be 0 or 1.
X will be 1. If it's 0, it's a big tragedy. We cannot have 0 in the denominator. Oh, if it's 0, it's a big tragedy. We cannot have 0 because 0 will be in the denominator. So yes, so this function will cross at 1, 0, the x-axis. Okay, good. For the purpose of what we're trying to do now, just find max, min, critical numbers. I did not specifically need to do that, but since we already have it, I will put it in. So g prime and g of x. It is very important, though, to see that the domain of this function is, that was one purpose, actually. The domain of this function is, can anyone give us the domain?
The domain of the polynomial?
No. This is not a polynomial. Anything with rational fractions like that is not a polynomial. But we already talked about the domain. So then what is the domain? Anyone?
0, 1.
So we already talked about the fact that everything goes except 0, right? This is the cube root. The cube root exists on anything, positive or negative or 0, but the only problem is that it's in the denominator and we cannot have 0. But the cube root is a friendly root. It takes anything. So the only problem is at 0. We already know that at 1, the function is 0. In a minute, we'll determine these. Okay, so let's continue with the first derivative. And I'm coming back. I'm going to copy the function so I can move that page away. So again, this is g of x, x to 1/3 minus x to negative 2/3. You could also write it like this if that's easier for you. It's the same thing. And you still get to the same thing. You find the least common denominator, and you have to multiply these two, and you get x minus 1. So no matter what you do, you still get to the same thing. You either change it into a fraction or etc. But I'm not going to differentiate this, and I'm not going to differentiate this because this is easier. So then g prime of x, can anyone help with the derivative?
It's
Isaac?
are you doing the bottom one or the top one?
No. Yeah, the top is the easiest.
Okay,
3 x2 1/3 minus 1, which is
minus
2/3. Yep. We bring this down, which is plus. And x2 negative 2/3 minus 1. Remember, 3 times 1.
That's negative 5/3.
That's it. Very good. Specifically here, factoring is extremely important. And yes, we're going to factor. What are we going to factor? Like before, in this case, I do have a 1/3 to factor, and x to negative 2/3 and x to negative 5/3. Which one is the smallest power? That one will go. Yes. Thank you, Mickey. Negative 5/3. Good. And now we have to discover what is left in parentheses. I start with 2 terms. I have to have 2 terms with plus in the middle. Who would like to help with this?
Well, the right term would be 2x. Yeah, just 2.
And what about this one? Exactly as you said a few minutes ago, from negative 2/3, I subtract negative 5/3. From negative 2/3, I subtract what I pulled in front.
So 1x 7/3.
Right? From negative 2/3, we subtract negative, right? So we have negative 2, but plus 5, which is 3, over 3, which is 1. Right? So negative 2 plus 5 divided by 3, which is 3, over 3, which is 1. Everyone in agreement?
Yes.
Perfect. So then this becomes basically x plus 2 over 3 and the cube root of x to the 5th power. Okay. So now we want g prime to be undefined or g prime to be 0. One or the other or both or none. Where is g prime undefined?